Okay, so let's start with the week 1 assignment. Okay, you can see the assignment, right? Assignment page.
Yes, sir.
Okay, so the first question is you have to say it's true or false. Okay. It's given that root 2 plus 1 by root 2 is rational. It's true or false. You have to prove it or disprove it. So everyone knows that root 2 is irrational, right? So you have to prove that root 2 plus 1 by root 2 is sum of two irrational may not be irrational, right? So a priori you cannot say that this is a irrational number or not. Yes. Okay. So how can you write this? So this is root 2 plus 1 by root 2, right? So how can just multiply root 2 by both sides here upper end. So it will be, you can write it in this way, right? Just multiply root 2 above and below, numerator and denominator. So now take out the root 2. So what is this? So this is 1 plus 1 by 2, right? So this means this is root 2 into 3 by 2, right? Now suppose this is rational. Suppose this is rational, then what is the definition of rational number? So if root 2 plus 1 by root 2 is rational, then you can write root 2 plus 1 by root 2 as p by q, right? Where p belongs to z and q belongs to natural number, right? So this is same as this. So what will be this? So root 2 into 3 by 2 is p by q, right? Or then what happened? So root 2 will be 2p by 3q, right? And so what it is saying that this is again a 2p by 3q. This is a rational number, right? So if we assume that root 2 plus 1 by root 2 is rational, we get that root 2 is a rational number. So which is a contradiction, right? So which is a contradiction. Which is a contradiction. So our assumption is wrong. So what will be answer? So root 2 plus 1 by root 2 will be irrational number, right? So this is false. Is it fine? If any doubt, then you can write it in the chat box. Right, so the first one answer will be false. It will not be a rational number, it will be again irrational number. Okay. So now move to the next question. What is the next question? You have to find the limit of this. So what will be the limit of this? Okay, so what is this? So you have to find limit x tends to 1, 2x minus 3 into square root of x minus 1 by 2x square plus x minus 3. So what you will do? So factorize the denominator. So what happened? So then it will be 2x minus 3 square root of x minus 1. What will be the factorization? So you can write it as it will be 3 times 3, so 2x square plus 3x minus 2x, you can write minus 3, right? So then what happens? Limit x tends to 1, so 2x minus 3 okay, 2x minus 3 is square root of x minus 1, and below it will be, so 2x minus 2x plus 3 it will be and x minus 1, right? And then here note that x cannot be 1, right? If x is 1, then the denominator will be 0, then it will not be well defined. So here x is not equals to 1. Note that, here I will write it. So this is 2x minus 3 square root of x minus 1 by 2x plus 3, and this you can factor as square root of x plus 1 square root of x minus 1. Here from there, after that I will write it here. Here note that x not equals to 1, right? If x equals to 1, then the denominator will be 0, as it should be non-zero. 2x square plus x minus 3 should be non-zero. Should be non-zero. Right? So as x not equals to 1, so this is non-zero. So you can cancel out from the numerator and denominator. So what it will be, limit x tends to 1, it will be 2x minus 3 by 2x plus 3 into square root of x plus 1. Okay, now if we, now what will be the limit? Now there is no problem, right? So now you can evaluate the limit. So what will be then the limit? It will be minus 1 in numerator, it will be 5, so it will be minus 1 by 10, right? Is it fine? So the answer will be minus 1 by 10. So the answer is this, right? If anyone have any doubt, you can write it in the chat box. Or is it fine? Then it's okay. Okay. Okay, now move to the next question. Then, so what is the third question? You have to find the limit of this x square minus 1 by mod x minus 1 as limit x tends to minus 1, right? So you have to find this limit of these functions. So okay, what happened? So as there is mod, what is mean by the modulus? So modulus is if x is greater than 0, then mod x is, so let me write it. What is mod x? Mod x equals to x if x is greater than 0, it will be minus x if x is less than 0, right? So this is modulus of x. So what will be the function? So this x square minus 1 by mod x minus 1, it will be two types. So if x square minus 1 by, this will be x minus 1 if x greater than 0, and if x is less than 0, what happens? It will be minus x minus 1, right? If x is less than 0. But here you have to find the limit as x tends to minus 1, right? So here it's 0 and it's minus 1. So you have to find the limit as x tends to minus 1. So whenever you want to find the limit, you have to look at on the neighborhood of that point, right? So as we have to find the limit around minus 1, so no need to consider as x greater than 0, right? So this part is irrelevant. So you only consider this part only. Here it's only, we consider this part because we are finding the limit as x tends to minus 1, right? So what happened? So we will only consider this limit x tends to minus 1, x square minus 1 by minus x minus 1, right? Okay, and so now what happened? Now factorize the numerator. So what will be the factor of the numerator? So it will be, you can write x plus 1 and x minus 1, right? And the denominator you can write like this. So now x cannot be minus 1, right? If x equals to minus 1, then the denominator will be 0, so it will be undefined. So x not equals to minus 1. So you can cancel out x plus 1 from the numerator and denominator. So this will be x minus 1 by minus 1, right? So what will be the, now you can evaluate as x tends to minus 1. So what will be the limit? Then it will be 2, right? So the answer will be 2. Is it fine for everyone? Anyone have any doubt? Okay. So let's move to the question number 4. What is the question number 4? Again, here you have to find the limit of cos theta minus 1 by theta square as limit theta tends to 0. So you have to find this limit. Limit theta tends to 0 cos theta minus 1 by theta square. Okay, right? So how can you write? This is limit theta tends to 0 cos theta, cos 1 can be written as cos 0, right, by theta square. Now you remember the formula, there is a formula for cos c minus cos d, right? So what is the formula? It is 2 cos 2 sin c plus d by 2 into sin d minus c by 2, right? So this is the formula for cos c minus cos d. Now in the numerator you can apply this formula. So then how you can write it? So limit theta tends to 0. So what happen? It will be 2 into sin. Here c is theta, d is 0. So apply this 2 sin. So it will be theta plus 0 by 2 means theta by 2. And here it will be d minus c by 2, 0 minus theta. So it will be sin minus theta by 2, right? And denominator as it is. So this. Okay, and you know the sign of this, you know also sign of minus theta is minus sin theta, right? So how can you write then? Then it will be limit theta tends to 0 minus 2 will be there, and this you can write sin theta by 2 by theta by 2 you can write, and again sin theta by 2 theta by 2. So what is the extra then? 2. So what will be the extra? These two we can. So you have to give, it will be 1 by 4 you have to write, right? Then it will be same. And now you know one result, that limit x tends to 0 sin x by x is 1, right? So use this formula. So then because as theta tends to 0 means you can write also limit theta by 2 also tends to 0, right? So then it will be minus 1 by 2, and this you can write sin theta by, okay, sin theta by 2 into sin, this whole square. Otherwise you can write this also, sin theta by 2 into theta by 2. Now if you take the limit, both this quantity will be 1. So what will be the limit? It will be minus 1 by 2, right? So the answer is minus 1 by 2. So this is the correct answer, minus 1 by 2. Is this fine for everyone? Okay, so if it's fine, then now move to the question number 5. Okay, so in this question there is a one mistake, mean the options are not correct. So let's see what will be the correct answer. So it's given if f is a function from r minus 0 to r, and what is the f? F is e to the power ln of x square. You know the ln and log, right? What is this? Ln means it is the base is e. When you write log base e, and log generally it's base 10, then you will write it as log, right? If it is base 10, then we'll write it log. So ln means it's here it base is e base, so it's what it will be. So e log, this is e x square, right? So this you know this is the property of logarithm. If this, then you can write it as x square, right? So f is basically x square on r minus 0, right? So what will be the range of f? So x square is always positive, so it's always greater than equals to 0, but as 0 is not in the domain, so its range will be, so range of f, it will be all such y belongs to r such that 0 is strictly greater than y. This will be the range, right? So this is the range, because here log we have, this is x square. Someone can say that here 0 is no problem, but right, we have defined in terms of logarithm log, and log is not defined at 0, so you cannot take 0 in the domain, so that's why it's open. You cannot take y to be 0, right? If we take 0, then this quantity will not be defined, because log is undefined at 0, right? So the range will be between 0 and infinity. So here the options are not one of these, so the options are here wrong. So this is the range of it, right? So what kind of these x square functions look like? So this is the x square, but here 0 is not there, so this is not there. This is y equals to x square functions. So range is, so this side it's x, it's y, now it's 0. So the range is 0 to infinity, and 0 is open. So this is the range. So any doubt in the question number 5th? Okay, if no doubt, then we can move to the next question. Question number 6. What it's saying, let x is the interval open 0 infinity. So x is the interval open 0 infinity. This is the subset of R. Now you have to tell what is the complement of x. Is it countable or uncountable? So what will be the complement of x in R? So x complement, what is the complement? So x complement will be minus infinity, 0, right? So this is the x complement. So you have to say that x complement is countable or uncountable. So it will not be, it will be uncountable, right? So this option will be false. Why it's uncountable? You know that any interval, you have, I think you have proved that 0, 1 is uncountable, right? This is uncountable. So you can prove more generally any interval where a is strictly less than b, this will be uncountable. Is uncountable. Same technique will work. How you will prove z 0, 1 is uncountable. So here it's also the interval, right? So this is again uncountable by the same thing. So x complement is uncountable. Means you cannot, means there is no bijection from the natural number to that set. So x complement is uncountable. So this, so it was saying that complement of x is countable. So this is false, right? So uncountable means you cannot enumerate this with indices in the natural number. You cannot write x1, x2, x3, dot 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 xn, dot dot dot, right? You cannot enumerate this. Okay. So is it fine? The question number 6. Okay, no doubt. Then we can move to the next question. Question number 7. What it is saying? The square root of a rational number is always a irrational number. So what do you think? Square root of a rational number, is it always irrational number or rational number? It can be rational number. It's true or false?
False.
False. Can you give some example?
4 is a rational number and root 4 is a rational number, that is 2.
Yes. So this is not always true, right? Square root of 4, this is 2 and this is not irrational number. So this is false, right? So it's always not true. It may be rational number. Okay, so 7 is done. Is it fine for everyone? Okay. But sometimes it may be irrational, right? If 2, then it's irrational number. So it's or not always irrational number. Okay, now move to the next question. What it's saying, let x and y are two rational numbers. Then there are 4 options. You have to say which will be true. So x and y are two rational numbers. Means what happens? So x you can write p1 by q1, where p1 belongs to z and q1 is natural number, right? For x2 similarly you can write or y, you can write p2 by q2, right? Where p2 belongs to z and q2 belongs to n, right? So what happens? X by y, is it always an irrational number?
No, sir.
It's not true, right? It will be rational. So it's defined whenever y not equals to 0, right? So what will be x by y? It will be p1 into q2 by q1 into p2. Here these two should be non-zero because it's defined means it's a non-zero. So this is again rational number, right? So the first one is false. X by y is always irrational, it's false. So what is the next? Xy is always rational. Can you say xy is always rational? So what will be the xy? So it will be p1 p2 by q1 q2, right? So this is again integer and this will be again natural number, right? So you can, this is rational number, right? So this one is true. Xy is always rational. What happened to x to the power 1 by y? Is it always rational? X to the power 1 by y. So what is x to the power 1 by y? Is it always rational or it may be irrational? Can you, if it may be irrational, can you give some example of x and y and it will be irrational number?
X equal to 3 and y equal to 2.
Yes, take x equals to 3 and y equals to 2. Then what happens? It will be square root of 3, right? And this is a irrational number. So x to the power 1 y is always rational. It's not true. The fourth one is saying that x plus y may be irrational. So let's check what happened. X plus y, it will be p1 by q1 plus p2 by q2. So you know that can this be irrational number? And it cannot be, right? Because this you can write q1 q2 p1 q2 plus p2 q1, right? And this is again a rational number, right? Some integer and natural number. So this cannot be irrational number. So fourth one is also false, right? So what we will get, that if x, y are two rational numbers, then x, y will be always rational number. So the second one is true. Okay. Any doubt? Okay, then we can move to the next question. Question number 9. What it's saying? Let f and g are two functions from R to R. And what is f of x is 2, this is a constant function 2, and g of x is x square minus 1. So you have to find the domain of f compose g. Okay, so f is a function from R to R. F of x is 2, and g is also a function. G is also a function from R to R. And g of x is x square minus 1. So how the composition is defined? F compose g, it will be again functions from R to R, right? So what is the f compose g of x? So what will be this? Means f of g of x, right? So this is the definition. So what is f? So what is g of x? This is x square minus 2, right? F compose g, right? This is x square minus 2, x square minus 1. Now what will be this? Okay. Now what will be the f of this? Then f is a constant function, right? Whatever is in the domain, it will always give the 2, right? So f compose g is again constant functions, right? So what will be the domain of f compose g? Means whenever, means its domain is also R, right? For all values of x, it gives the value 2. So domain of f compose g is the real number, whole real number. So the option 4 is correct. Is this fine for everyone? Okay. So this one is done. We will now move to the last question. You have to again find the limit of these functions. What is this? F of x equals to 1 minus, sorry, f of x equals to 1 minus x if x is less than 1, and x if x is greater than equals to 1. You have to find the limit of this. So first you have to guess what can be the limit. So means you have to come from the left hand side. So this, right? So this is if it is 0, it's 1. So for x greater than equals to 1, it's like this functions, right? Oh no, sorry. So at the point 1 it's 1, So it's look like this. And x less than equals to 1, so at the x equals to 0 it 1, and at x equals to 1 it will give the value 0, right? So this kind of, so its slope is -1, this, right, at 0 point this is 1. Now you have to find the limit of as x tends to 1, this. So means you have to come from the right and also from the left. You have to, so that if the it will give the same value. This, so if this gives the same value at x tends to 1 from the x positive, x 1 plus 1 minus, then we can say that the limit exists, otherwise limit will not be exist, right? So is from the picture you can see that if x comes from the right hand side of, if x comes from the right hand side of 1, so where it's 1 is means it 1 is included, so then it gives the value 1, right? And if it comes from the left hand side of 1, then it gives the value 0. So right, so from here you can see that limit cannot be exist, right? So that you have to prove, right? So you have to show that these two limits are different, as x tends to 1 minus 1 1 plus, these two limits are different, then the limit cannot be exist, right? So first claim that limit x tends to 1 minus, from whenever come from the left hand side of 1, so then fx, what will be the value of this? We claim this will be 0, right? So we'll prove this. So how to prove this? So means what you have to show, mod of f of x minus 0, if we, this can be made less than epsilon in the neighborhood of 1, in the left hand neighborhood of 1. So what is this? So fx is, for x less than 1, fx is 1 minus x, right? So this is 1 minus x minus 0, so means this is mod 1 minus x, right? So you want to make this is less than epsilon, you have to choose some delta, right? So if you want to make this for epsilon greater than, you start with some epsilon. So if you want to make this to be less than epsilon, choose what you can choose, you can choose delta to be epsilon, right? So then what happen? So it will be then 0 less than, it will happen, right? Then what happen? So choose delta, then if 0 less than, as x is less than 1, so 1 minus x is less than delta, then as this will be less than, we are choosing delta to be epsilon, so this is all less than epsilon, right? So then mod of f of x minus 0 is less than epsilon, right? So what is the meaning of this? So this is the meaning that limit x tends to 1 minus f of x is 0, right? So those, we have proved that limit x tends to 1 minus f of x is 0. I have to prove limit. Now claim that, claim limit x tends to 1 plus, what will be the f of x? So now it claim that limit x tends to 1 plus, limit will be 1. That you have to prove, right? I'll just delete it. Okay. Just forget about this. So we'll prove this one here. So again, how to prove this? So for epsilon greater than 0, you have to, so f mod of fx minus 1. So when x tends to 1 plus, what is fx? So when x is positive, when x is greater than 1, fx is x, right? So then it will be mod of x minus 1, right? You have to make this to be less than epsilon. So if you make this to be less than epsilon, what you will choose? Again, you can choose delta to be epsilon, right? So whenever 0 less than, so here x we are taking positive, right? So whenever x minus 1 is less than delta, then what happens? Then this will be less than, as delta is epsilon, this will be less than epsilon. So then f of x minus 1, this is less than epsilon. So what is the meaning of this? So this is the meaning that limit x tends to 1 plus f of x is 1, right? So what we will get? Limit x tends to 1 plus f of x is 1, and limit x tends to 1 minus f of x is 0. So we get two different limit. When you are coming from the left hand side, we get 0. When you come from the right hand side, we get 1. So this is the meaning that limit will not exist, right? So the fourth option is true. Limit does not exist, right? Okay. Is it fine for everyone? Any doubt with this? With this we have done. So limit does not exist. Right. Okay. So any doubt? So we have done all the questions. If you have any doubt from this, the questions, you can ask question. Any doubt regarding this? You can write it also in the chat if you have any doubt. Or if you cannot understand, I can explain it again. Is it fine for everyone? Yes? Any question or fine?
Sir, I wanted to ask how
Yes.
do we access the course notes?
Oh, course note. I think only the video you can see. There is no course note available.
Sir, actually in the video lecture, sir has mentioned that some additional proofs are mentioned in the notes. So I just
Additional
wanted to know how do we
notes.
see them?
Means,
Additional proofs of it. Yeah, in the video lecture, the sir had mentioned.
okay, I think then I think he might add. He might add it. Or if I get somewhere, okay, then I will see if I can find it. Any other doubts?
Sir, in the video lecture, using formats number, they had proved the infinity of prime numbers. I could not understand that part. Will you please explain that?
Okay, means I have not seen the video. Can you explain which part you have not seen? Means you have not understand?
So using formats number, the infinity of primes was proved.
Okay, so means I have to see it. Means I have not seen it. Means what is done. Okay, I will see it then.
Okay,
How
sir.
is okay? Fourth again. Explain again. Okay, fourth one. Fourth one. Okay. So you have to find the limit of this as theta tends to 0, right? So right now you cannot evaluate this because at theta tends to theta equals to 0, numerator denominator is 0, numerator is both 0, right? So you have to simplify it. So the numerator you can write it as cos 0 is 1, you can write 1 to be cos 0. So this will be cos theta minus 1, so it is cos theta minus cos 0. Now you know the formula for cos c minus cos d, right? 2 into sin c plus d by 2 into sin d minus d by 2. So use this here. C is theta, d is 0. So then use this formula. Now you write it in this form. You know the formula of this sin x by x as limit x tends to 0 is 1. So try to use this one. So combine this sin theta by 2 and take 1 theta from here. So just write it sin theta by 2 and theta by 2, right? And for the next one, take the minus out, sin theta by 2 and theta by 2. So 2 is extra here. So that's why I have inserted this 2, 1 by 4 is to make this correct, right? So now as theta tends to 0, theta by 2 also tends to 0, right? So I change it to theta by 2 as I have to make theta by 2 tends to 0, right? And as limit theta by 2 tends to 0, you know that sin theta by 2 by theta by 2 is 1. So this part is 1 and this part is also 1. So only get minus 1 by 2, right? Is it fine? Gemini? Do you get it? Okay. Any other doubt? Yes, any other doubt? No doubt. Okay, then we can stop for today. Let's meet on the next week. Is it fine? Yes, Abdul? Any question? Okay, let's stop then. I am stopping. Stop presenting. Okay, bye. Okay, thank you.